neutron deficient or neutron poor radioisotopes and how they would undergo decay. So neutron poor isotopes. So one example of a neutron poor isotope is fluorine-18. Stable isotope of fluorine is normally fluorine-19. Nope. So you can see clearly that there's one less neutron in fluorine-18 than what there is in fluorine-19. So what happens in this particular instance, in order for the neutron poor isotope to become more stable, is that one proton in the nucleus of the fluorine-18 transforms into one neutron and what we call a positron, which is essentially antimatter. Okay, so positron, it's an antimatter of the electron. Okay, and this is what I said we're going to talk about a little bit later. So this is also a form of beta decay, but in this particular instance, it's beta positive decay because we're looking at the emission of a positron. So because the atomic number has now gone down due to the transformation of a proton into a neutron, we're going to have to balance that and say, well, we've got 8 for the atomic number. The mass is still the same because a proton and a neutron have the same mass. So we've got element 8. If we look at our periodic table, that's oxygen. And what's been emitted from this nucleus is that piece of antimatter, or the positron. So fluorine-18 is quite interesting. It's used in medical applications. And what we do with it is we attach it to a glucose molecule. Okay, now glucose molecules will travel to sites of high cellular activity. So, you know, for example, the brain, tumor cells especially. And it will decay only over a period of hours. So as opposed to carbon-14, which has a half-life of 5,730, fluorine-18 has a half-life of just a few hours. Okay, you can look up the actual half-life for me if you don't mind. Now, when the positron is released in the body, it's going to encounter electrons. Okay, we're all made up of atoms. So the positron is going to encounter the electron. Now, these two are antimatter. Okay, well, the positron's the antimatter, the electron's the matter. And when they come into contact with each other, they actually do an interesting thing where they annihilate each other. Okay, so this is a particular instance where matter is transformed into energy. Okay, 2 gamma rays are emitted, and they are actually emitted at equal and opposite intensities. So what happens there is that a gamma camera would then be used once again, okay, in order to pinpoint the source of the gamma rays. So wherever this positron has been emitted, so wherever the fluorine-18 has been used up, okay, on the glucose molecule, it will come into contact with an electron in a fairly short space, you know, in traveling, okay, as we're all made up out of atoms. And these 2 gamma rays will be emitted at that site where they annihilate each other. So the gamma camera is then used to detect the rays, and it can pinpoint the source of the fluorine-18. So where's the fluorine